I guess I'm just going to go ahead and shut that down. Okay, there we go. Now I'll get this back up again here. Get all the way to the top. There we go.
That was a great presentation, Steve. Now
Wasn't
we've
it,
seen it
though?
all,
Yeah.
and we're done.
Well, you know, I figured, hey, I don't want to waste time here. Let's just blast through this stuff and no. I assume there were no questions or concerns through that that blinding slideshow. All right. Well, welcome everybody to the November meeting of the Seattle Robotics Society. Glad you guys could join us this morning, and we shall see what kinds of interesting things that we discuss today. Here's the general agenda, and I retitled the post meeting thing rather than calling it a workshop is probably really kind of a misnomer. It's really just more of a robotics discussion. So after the meeting, we'll actually stop recording, and people can hang out and just talk about whatever. So kind of like the mingling that we used to do after our meetings at the end, when we had in-person meetings. The general agenda is what you guys have been here before. It's just gonna follow this this particular outline. So let's see, if you are not actively sharing, appreciate it if you just mute your microphone. So if in case there's any background noise around you or behind you, a wolf comes in and tries to attack you and starts making a lot of loud growling noises and stuff, that way it doesn't disturb the rest of us. So do use the Zoom chat to capture links and other information that to share during the meeting, and then that'll be included with the post meeting stuff. Let's see, there's been nothing new regarding a physical location. Yeah, right. Been nothing new about a new physical venue yet. I'm hoping that something will appear here soon. So we'll let you guys know. Probably put it out and announce it out on the groups.io list when we hear something, and then it'll show up on the website. Speaking of the website, the new SRS website has gone live. So when you go to seattlerobotics.org, you will see something different than you've seen for the last 20 something odd years, and it's still definitely a work in progress. My son and I are kind of working to put all the pieces that were there before back. So you may find some things that it's like, where did this go? Where did that go? Don't sweat that. The intent is that it will all be back. It's just going to take us a little time to get it all there. So anyway, but when you have an opportunity, just pay a visit, and if you have any general feedback or regarding the look and the feel and everything like that, I'm happy to receive that. We're using a picture, a background picture from the field house that we used to meet in. For lack of anything better, I figured, well, there's probably some good image out there that we could use as an alternative, but hey, it was the closest thing we could find that sort of made sense. So anyway, but all of that's adjustable, obviously. Our plan is once we get to in-person meetings, that we will continue to do online. I don't know exactly how that will all work, but I know some of you are not locals here for Puget Sound, and you'd like to be able to continue to join us for the meetings, and we have every intention of enabling that. So for those that are locals, I might need a little bit of assistance with some of the equipment and running things to make that happen locally. I'm continuing to do robotics classes for junior high kids at a church near us, and these are some of the robots that we've been playing around with. And the little blue M-Bot there, that was a Dave Anderson suggestion, and I like it because the little, you see the little 3 blue robots there, that's actually the same kit. So it's configurable either as a tread based robot, a 2-wheel plus rear caster, or a 2-wheel balancer. So the control module has a variety of sensors and LEDs and other things in it that allow you to create a balancing robot. And I showed the kids these pictures, and we watched some videos of what these guys could do, and they thought, "Whoa, that's pretty cool." So I'm excited about the possibilities. So and then of course the 4-legged walker Mechamon there, that's always a hit. I mean, that, and little kids really love those things, but the bigger kids love them too, and they like to battle with them. So I have a pair of those, so they like to crawl them towards each other and such, and attack each other. So anyway, this has been fun. A little bit later, James Newton is going to share with us on whatever it is that he wants to share with us. Yeah, go ahead. Why don't you go ahead and unmute yourself there?
So I want to be completely honest with you guys. I got really sucked into the Hackaday Remoticon, which started yesterday. I don't know if you guys are aware of Hackaday, but it's a great little organization that really supports all kinds of open source hardware and open source software. And they have a prize that is sponsored by somebody every year, and they have been doing the announcement is actually tonight for who won it. I think the winner is getting like 15 grand or something like that.
Wow.
The amount that they give away varies. Haddington Dynamics won it in 2018, and we got, I don't know, what was it, 50 grand, something like that, when we won it. So it's a fairly big deal, and I was asked to be one of the judges. But more than that, what's really cool about it is just that it's so incredibly cool just being around other people who are doing this kind of stuff, in the same way that it's really cool being around you guys. But I've had 2 groups, sort of competing for my time leading up for this, and I intended to kind of put together a presentation for today and have totally failed. So this is going to be a horrific ramble, and what I'm hoping we'll do is that I'll start presenting some ideas, and I'm really hoping that people will use the chat to just say, this is interesting, or nah, everybody already knows this, or I don't see the use in this, or whatever, and just be blunt and let me know whether or not you want me to switch to a different topic or go on to something else. So, and I'll just try to kind of follow the votes and switch from topic to topic, and hopefully people will have lots of questions.
Right.
And we'll turn it into a discussion of James Newton's weird ideas and interesting thoughts.
Would you like me to retitle the slide then, something like that?
No, that's okay. That's all right. I don't think it's worth the retitle. I'm going to start with the SDMG WebBot anyway, so that's a good start.
Yeah, and yeah, I'm going to come back to that in just a sec here. So let's see. Let me. Come on. There we go. Yeah, thanks, James. Yeah, he'll be coming up after the break. So. Presentation ideas. I'm always interested in ideas and suggestions, and in particular, just my monthly reminder on the February meeting. We will be meeting at this one particular day at between 3 and 5 p.m. Pacific time. Probably not. No, it's actually not PDT anymore, right? It's just Pacific time, Pacific Standard Time. To accommodate a presenter who will be presenting to us live from Japan. So it's going to be in the morning. It'll actually be Sunday morning for him presenting to us. And so, and I will show you the lineup. And as you can see, if you flash back to your photographic image of this slide from last month, you will note that there's more stuff in it now than there was. And right now, aside from next July, I have stuff booked all the way through next September. So we have a great lineup of stuff coming. Not all of this is going to show up on the website. My son has a thing where I'm using a special Google Calendar where he pulls data from that to populate the website. So I think it's currently set up to do about 5 months into the future. So you can look on there and you can see what's coming for the next 5 months, and then those will automatically update. So anyway, you can kind of see the variety of things there. The February meeting is highlighted because of that special time. I got the PST correct there. So I just didn't have it correct on the previous slide. Like I say, I rather expect that I'll be able to fill the July position here relatively soon. So we will have nearly a year's worth of advanced presentations lined up. So it's been since we've gone virtual with the meetings, this has actually become a whole lot easier to book things, because I'm no longer limited to just people that are Puget Sound locals. I can now go virtually anywhere in the world that's within reason. There's a few places where the time zone differences would be a little weird for us, and even accommodating, it'd be very difficult for us to shift our meeting to a reasonable time that can accommodate some of the time zones. But for the most part, we can bring in people from practically anywhere. So anyway, if you come across something that sounds interesting and you'd like to point me toward them, do that. If you would like to present, I'm more than happy. And like what will probably happen today is perfectly fine. You don't have to have some canned, polished presentation, flashy PowerPoint slides with all kinds of cool transitions and all that stuff. I mean, if you just want to have a discussion, and you got something and just back and forth kind of chatting, I mean, that is awesome. And a lot of times that's really fun to just talk about things, and the more interaction, the better. So keep that in mind. I've moved the facilitated discussion out to next August. I had been using that in I think it was in April. I was kind of using that as a filler, and got a presenter that's going to pull into that spot. So facilitated discussions, I think, are kind of similar to what we will probably do today. Where just, it's mostly about you guys contributing. So some of the topics that would be really fun to discuss. I'm no expert on any of these, by the way, but but it's easy to go and do internet research and find information about them. And that's kind of how I put these together. I just go out and I look for what I can find about them. And so anyway, if you know of somebody or who would be interested in maybe leading a discussion with us about some of these topics, doesn't even have to be a presentation per se. Just, we'd like to talk about this, maybe pull a few things from the web and use this kind of a seeds for a discussion, starting discussions. That would be awesome. So I'm going to let's see. So last Saturday we had our second virtual Robothon exhibition event. And I was going to kind of turn this over to Lloyd to see what he can share. Kind of we're going to be meeting next month, I think, to kind of talk about when we want to do the next one. So go ahead, Lloyd.
Hi there. So can folks hear me? Okay. So yeah, we did our virtual Robothon. We had 5 presenters. Otto Dave was one of them. One or two of the folks from DPRG, Jim Kinsvader, also presented. If you want to see the video, it's up on the SRS and more. So we did tape it. Yeah, I don't have a whole lot to say about it. Actually, it was a lot of fun and it was pretty good success. We do plan to continue doing these even after we go back to in-person events, because they're actually working out pretty well. Yeah, if anybody has any comments or thoughts, just let us know. I think our meeting is, we're meeting on December 9th to kind of review this one and plan out next year. So. Yeah, not a whole lot to say on it, but yeah.
Okay. Probably looking at somewhere first quarter to second quarter, somewhere in that time frame.
Yeah.
There's about 4 months difference between these two, so that could be potentially March, April-ish time frame. We'll try to avoid conflicting with other big events that might be happening. So that's kind of part of how we figure out where we want to land these things. So, yeah, and do keep in mind, presenting and something like this, it's pretty low key, pretty informal, and it's fun. They can be as interactive as you like. If you want to just kind of throw something out there and then maybe do a little Q&A at the end, or if you want to have interaction as you go, it's your choice. It's relatively brief, I believe. I don't know how long the speakers lasted, or how much time you gave the speakers. I wasn't able to watch the event yet, but
yeah, we ran for 20 minutes per. So that seems to be about right. So our general format is we'll run 3 speakers for 20 minutes, take about a 20-minute break, 2 more speakers for 20 minutes.
Yeah.
And then break into some general chit chat.
Yeah. So it's relatively short. I mean, compared to a presentation at this meeting could last an hour if that's what you need. So there's you're welcome to cover the same topic here. You have more time and more opportunity to open the discussion.
Hanging around me, dog.
And do have a more of a Q&A. All right. Who's got their mic on? Let's see if I can. Oh, Greg. Okay. There we go. Okay. So anyway, yeah, so keep that in mind, somewhere next spring probably. And if you've got anything that seems like it would fit, do go watch the videos, SRS clips and more. And there will be a link from here. Actually, I'm gonna, let's see. Oh, I did. Yeah, I guess I did talk about the website. The previous meeting information and stuff hasn't been populated into the website yet, so that's coming. So, but if you go to YouTube, search for SRS clips and more, you will find all of the videos, the meeting videos, as well as these exhibition event videos that we've recorded. So, you can always go there and watch things. So, we still have our kits. I updated the pictures for these things, so this actually, so that you'll notice that the pictures are actually accurate now, I believe. We have an Arduino Uno based robotic kit available for $125, cash, check, or charge. And we have a Parallax propeller chip based version of this kit, also available for cash, check, or charge. So if you're interested in one of these, you can reach out to me. Lloyd also has some of these, so you could also reach out to Lloyd Moore, and we'll figure out a way to connect up. We're both up here in Puget Sound. I'm in Federal Way. Lloyd's in Kent. Is that right, or Renton?
I'm in Renton.
You're in Renton. Okay. So Kent, Renton, and Federal Way. Lloyd works from home, so I think he's not too difficult to connect with, and I'm retired, so I have a little more flexibility to get around. So if you're interested anyway, just reach out. You can just use the Seattle Robotics Society Gmail for general contact regarding this, and then we'll get back to you. The virtual robotic discussions will just happen after the meeting. The Zoom call will just continue until people are done, and but it won't be recorded. So, and now it's your turn. And I'm sure every one of you's got something to share today. I'm counting on it. But in case you didn't, I have a few things that I can use. So, let's. I'm going to go ahead and stop sharing, and I'm going to turn it over to you guys. So who's got something that they would like to share about or show us? Come on, don't jump all in at once. Come on. I know somebody's got something out there.
They won't let me take the rocket engine home, Steve. I don't have anything to show.
No takers?
Can we share something that somebody else did that we think is freaking cool?
Well, that's all I was going to do. So, sure.
Oh, I thought it had to be something that we were working on.
Oh, no. If you found someone on something, go ahead.
So the problem here is that I don't have this queued up. One of the guys who applied to the Hackaday thing is doing something that I'm just going to describe for a second while I try desperately to find that stupid thing. So basically being able to reuse filament for 3D printing is just and the whole problem of plastics, just in general, the problem of plastics is really a huge problem. So what he's been able to do is come up with an extruder for a 3D printer that actually just takes chopped up plastic dust. So basically, if you've ever done 3D printing, you know half your prints fail. What he does is he just takes the failed prints and he puts it in a blender. And he literally just, plays will it blend with it, right? And then takes the result of that out and makes it and sieves it so that it's all more or less the same. So that it's more or less all the same, size. And then he puts it into this extruder, which goes on the printer. And it just works. It just actually extrudes. And this is something that, people have been trying to make pellet extruders for years and years and years and years, and they've had a heck of a time with it. But this is the guy's webpage. He goes by Homo Faciens, and he's a German guy. Absolutely love his I'm lagging a little bit here all of a sudden. I absolutely love his accent. But what he's able to do with this extruder is just directly print with, the particulate matter from chopped up plastic. So, and there's no reason why this has to be limited to individual, like 3D prints that are taken up. But what he does is he just uses a stepper motor with a reducing gear. The shaft goes down to not an auger, and that was his big discovery. Is everybody wants to use an auger to do extrusion, and you can't. This little pink guy right here is actually a hopper, and the screw then feeds that down into the extruder head, and out it comes. So that's the basic idea of it. And that seems really simple, but the key point is that he got it working. And then what's really interesting about it is this top picture here, this golden material, because it's just extruding with particulates, with granules, he's able to actually extrude granulated sugar. So he's taking sugar and extruding it, okay? And the idea here is that it's too brittle to make into a filament. Even if you had something that would make a filament, it would be too brittle to feed. But what's wonderful about sugar is it's extremely brittle, so it just cracks away instantly as soon as you put any pressure on it, and it dissolves in water. So it's the perfect dissolvable support material. So if you make a printer that has two of these extruders on it, one for plastic, one for sugar, then you can 3D print with sugar for the support, and then 3D print with plastic for the non-support. And the combination gives you something that's, first off, reusing plastic, And then number 2 has this support material that's super easy to remove. So anyway, I thought that was worth taking a look at. I'll post his link into the chat here.
Thank you.
I was super impressed with it.
That is ingenious. It really,
That's really clever.
incredibly ingenious.
Isn't that wild? And I stay awake at night worrying about plastics in the world. I mean, it's a really big thing. They're being found in our water and our food. They get ground up in the ocean and on the beaches, and so reusing plastic is really an unsolved problem. The recycling efforts are not very good, and I hate to think that those of us who do 3D printing are contributing to that with our failed prints. Besides the fact that filament is freaking expensive. I hate it whenever I have to buy a new roll of this stuff. So I'm really excited about this. In my other spare time, which I don't have, I want to build one of these and try it out.
Yeah. So the actual little hopper thing, is that something that he just purchased? Or where did he get that from, or did he say?
He made it, and all of the files are available and shared on that same website. You just have to scroll down a little bit and look at it. So the actual physical hopper is 3D printed, and that's kind of the reason why, I don't know if you noticed, but it's this weird pink color. It's because it was a combination of some white filament and some red filament and some blue filament. He just blended it all together, and then took it out, and then he actually made the extruder, and he had to do some really kind of weird stuff in order to get the extruder to not clog, which is a big problem with these like pellet type extruders. So yeah, that was his big contribution to it, was actually getting the stupid thing to work and building it. And it's quite reliable, as you can see. It printed like the most of a rocket there, and it actually, there's a drive gear up at the top, a large drive gear, which is, I don't know, like a couple of, maybe 2.5 inches in diameter or something. It's driving a nut, which is soldered onto the top of a screw, which is his little thing that pushes it down in there. And that nut twisted inside the plastic and wore the plastic out. So what he had to do was he put another nut on top of that nut in order to push it down to a part of the plastic that wasn't jammed up yet. And then he used that to 3D print a new gear with an improved design that hopefully wouldn't have the same problem. So he even used a partially broken version of this extruder to print a new part for the extruder, which is just like the ultimate rep wrap thing.
Yeah. Huh. That is cool. Thank you for sharing that.
I don't know if any of you guys do 3D printing, but if you do, that's something to look into.
Hey, Steve, I remembered a video that I saw a while back that might be good to share.
Sure.
Okay, let me share a screen here. Okay, you guys see a funny looking guy without trying to talk?
Yep.
Packing warehouse in the southeast of London. Folks have ordered their groceries online, and instead of people walking up and down the aisles of a traditional grocery store to pick up items, these little devices move more than 1 million items every day between them. Instead of trying to build machines that fit into a world designed for humans, this entire facility, the size of 7 football fields, is custom built to make this as efficient as possible. I cannot get across on camera just how incredibly large this whole place is. The top speed of those boxes is about 14 kilometers an hour, and they pass within 5 millimeters of each other when they move. So, how many robots are there in the hive? Well, that depends on how you count them.
What you're looking at behind me is the hive. We've got the grid, which is the metal structure. It's filled with products. So that product is housed within what we call totes, or these open boxes that you can see at the top of the grid. We have around 2,300 bots, and they move the stock around the warehouse so that we can pair it up with customer orders to be delivered. The bots will move in the X and Y direction. They can also move in the Z direction. So we have a cable hoist system that means that they can lower down a gripper assembly and grab onto the stock that we have in the grid. In some areas we have as deep as 21 totes all in a line. We have sensors underneath the bot that mean that every time it passes over one of the squares on the grid, it has a laser underneath it that can tell when it moves over that cell. So it will say, I've passed a cell, I've passed a cell, I've passed a cell. We have around 58,000 different types of individual products within the grid. We'll use the huge amounts of data that we gather to understand what customers are most likely to order and place them in the easiest to reach locations for bots. All of that combined means that we can have stock into the warehouse and out again from our suppliers into a delivery van in just 5 hours.
The robots deliver their crates over to the packing area. Some of that packing is done by humans, but there are mechanical arms as well. One of the big problems they've got to solve is that grocery packaging is designed for people, and the interactions between all the objects they deal with can be complicated.
Currently we're standing underneath the grid structure that we saw earlier. The robots that we saw are actually dropping off products to the station. Once they're dropped off, they become in control of the robot, and the robot decides how to pick them before the grid robot picks up the tote and takes it away again. There's 2 3D cameras above the totes, so it takes an image of the storage box before it picks from it, decides on the best grasp point, confirm that the product is correct, and then place it into a customer shopping. And it's doing all of that on live customer orders. We make sure that we don't mix something that was heavy with something that's soft. There are things that the robot can't pack, things such as very, very heavy, very large, or very fragile items, but there's a lot of range in between that.
It's fairly safe to call each individual packing arm a robot. Each one has a separate controller, and it has to make a lot of decisions in real time using cameras and sensors on each individual arm. But here in the Hive, it's not quite as simple.
Controlling all of this is what we refer to as the hive mind. So this artificial intelligence system that controls everything. Once the stock comes in, from that exact point that it enters the system, the hive mind will track its every single movement. The hive mind will tell the bots exactly where they need to stop, but it is the bot's control system that allows it to follow a movement profile and stop exactly as the hive mind expects it to. There's just a 5mm gap between bots, so that's both as they pass each other and if they stop next to a bot as well. This bot with the orange light may have experienced something within its sensors and all of those readings it's taking, that when it feeds that back to the hive mind, it's not quite what the hive mind was expecting, so it just brings it to a safe stop for investigation. We do have a number of grid operators that sit at the edge of the grid, and they're able to use our CCTV system that we have above the grid to look at exactly what's going on with that bot, and they can try and fix that remotely and send commands to the bot wirelessly.
The boundary between individual and group is a little blurry. Is a termite colony a collection of individuals working together, or one big superorganism? Is the microbiome in your gut part of you? Because in the last couple of decades, scientists have started to work out that the bacteria in your digestive system produce and consume neurotransmitters that affect how you think. But most people wouldn't consider their gut bacteria to be part of them. We tend to ascribe intelligence and identity to things that act at roughly our scale. It's easy to look at the Hive, see the moving boxes and go, okay, 2,000 robots. But with only one controller and the boxes just following the paths they're given, I'd say there's a good argument that that is one robot with 2,000 ways to interact with the world. Thank you so much to everyone here at Ocado. There is a link to them and more about their technology in the description.
Well, put that post the link to that in the chat there, Lloyd.
Okay.
So I have to be really careful about what I say about that since I now work for them.
Oh, do you?
Oh, you really?
Yeah, they bought Haddington Dynamics, so that's, those robots that you saw doing the picking are, almost certainly going to be replaced.
Huh.
Wow.
Soon. I don't know if you guys are aware that they're building those in the U.S., mostly on the East Coast for Kroger. Kroger wants to move into some of the states where there are a lot of people doing online shopping now, but they don't want the expense of opening stores. So instead, they're opening those CFCs, they call them, customer fulfillment centers.
Do you have a feel for how many of those there are around the world? I mean, this looks like it was kind of a demo first build type of thing, but it looks like something they plan to replicate all over the place.
I'm actually probably not allowed to give an exact number, but it's a lot.
Wow. Yeah, that's what I was thinking.
They just inked a deal with Japan. That's public knowledge, that they are now building one in Japan. And so just the thought that the Japanese are buying robots from the British. There's something about that. It just kind of does.
Yeah, that's a reversal.
Yeah. There's, what is there, 4 going in the United States? I think there's 3 currently operating, if I remember correctly.
Wow.
So yeah, it's interesting because what they've decided to do is just say, well, we're not going to build a store. We're just going to build a warehouse, but we're going to put this grid on it and turn it into a CFC, and then people can place their orders. And over in the UK, you can place an order and have your groceries in an hour. I mean, that's from putting in the order to the robots picking it to a delivery driver driving it out to your place. Now that's like if you're in London, right? Or, someplace that's, really close to the CFC.
Right.
But still, that's freaking incredible. And you may have noticed those are the reason why they're different from Amazon, or at least what I think is the biggest difference is, did you notice how fast those robots are moving? I mean, they scream down those aisles.
Yeah.
Whereas the Amazon robots, if you watch them, they're really, really slow. And of course, the cost of building that grid seems like it would be higher, but they don't have to put in the micro GPS systems that Amazon's robots depend on. And the robots are a lot less expensive to build as well. So, it's advantages and disadvantages.
Sure.
Everybody should invest in Ocado. I think I can say that. I own Ocado stock, so maybe I'm not allowed to. I don't know.
How do you spell that? Oh, there it is. I see it.
Yeah, the stock is OCDO, and it's on the London Stock Exchange. But it's OCADO, and it's the end of avocado. So take ava and then Ocado.
Well, that is pretty cool. Thank you, Lloyd.
Yep.
Anybody else? All right, let me pull this one up here. And as soon as I get this going, I'll share my screen. Let's see here. Okay, so some of you, I'm sure some of you have heard about this thing. This is basically a CNC gardening robot, I guess you could call it. I'll let you just kind of watch the preview video here a little bit, and then they actually have a video with sound where they kind of explain how this thing works. But one of the things that was really cool about that I thought cool about this thing is the fact that it not only plants and waters, it also weeds. So this thing can, you can choose how you want it to put, what you want it to put in there, where you want it to put it, the layout, and it will, it completely takes care of your garden. So it was like, oh man, that's like, this will be so much fun. So let me go find all right, y'all seeing that?
Yep.
The current food production system is broken. Individuals, families, and communities no longer have control over how their food is being produced, and as a result, our health and the environment is in jeopardy. Let's take back control. FarmBot is humanity's open source CNC farming machine that automatically grows food for you right in your backyard, keeping you in complete control. FarmBot precisely sows seeds in any pattern you want and then waters each plant based on its type, age, soil conditions, and more. Using the onboard camera and advanced computer vision, FarmBot can scan your garden to detect weeds and then take action immediately. You can monitor your garden and plan the season from any phone, tablet, or computer. No coding is required. Using the Farm Designer, you can lay out your plants like a video game, and with built-in data for common garden veggies, you'll be guided through creating an optimal layout each season. Our custom sequence editor offers a no-code programming environment that anyone can use, even young and non-technical users, to program their device to take care of plants just the way you want. And with support for variables and traditional programming logic, power users can explore complete freedom and control. We've gone to great lengths to design, manufacture, and source only the highest quality components. And because everything is made from corrosion-resistant aluminum, stainless steel, and UV-resistant plastics, FarmBot can be placed indoors, in a greenhouse, or outside. We've come a long way since the 3D printed prototypes from years past. Meanwhile, the brains of the FarmBot are Raspberry Pi computers and our custom-designed Farmduino microcontrollers. Combined with powerful stepper motors and trinamic drivers, FarmBot can position the tool head with millimeter accuracy. We offer FarmBot in 2 models. FarmBot Genesis is our top-of-the-line, fully customizable kit, suitable for cutting-edge research and high-end gardening. The universal tool mounting system allows Genesis to automatically switch tools for different jobs. Included are the seeding, watering, weeding, and soil sensor tools, and new additions are in development. Meanwhile, our FarmBot Express line is designed and built for everyone. Coming 95% pre-assembled in the box, Express models are ready to be set up quickly and easily and perform the basic functions needed to grow a garden. Our Express kits are the most affordable FarmBots we've ever created, with the aim of bringing this technology to as many people as possible. Both FarmBot Genesis and Express come in a standard size that's perfect for backyards, classrooms, and research labs, as well as XL sizes, good for families, school atriums, and experimental production. To date, we've shipped nearly 2,000 FarmBots to customers in 75 countries. In schools, FarmBot serves as a practical, engaging, and fun hands-on tool for teaching and learning robotics, agriculture, biology, and many other STEM subjects. Whether it's an elementary student's first time working with a real robot or a graduate student developing the next innovation in agriculture, FarmBot is inspiring the next generation of farmers with educational experiences and research opportunities like no other. At home, FarmBot is used to grow veggies automatically, freeing you from the need to tend to the garden when going on vacation or when life gets busy. Plus, with FarmBot under your full control, you can rest assured that the quality and freshness of your produce will be second to none. And on the cutting edge of the future of agriculture, researchers around the world are using FarmBot to automate and run experiments on new varieties, inputs, and growing methods. Even NASA is looking into how FarmBot can be used for food in space and on the moon and Mars. All of this incredible innovation is because FarmBot is 100% open source. That means that all of our 3D CAD models, software, and documentation is available online for free for everyone to modify and use for any purpose. Want to design your own tools to give FarmBot new capabilities? Go right ahead. Inspired to go off-grid with solar power and a custom power supply? You can do that. You could even develop completely new versions of the FarmBot based on our existing library of components. We want you to join our community of DIY food enthusiasts all over the world who are helping us build the open food future. So check out our website to order your FarmBot, and together, let's take back control of our food. Thank you.
Well, what do you think of that?
You guys are just hitting everything that I'm into. I've been following them for years, and actually part of the presentation I was going to give today hits on what I think would be an improvement on that.
Well, please do include that.
Yeah, and I've actually done a whole thing on how to grow food indoors in a semi-automatic way, which is actually up over my head right now, growing me radishes and cherry tomatoes for my salads. It grows lettuce and stuff like that as well, but I've kind of been pushing it to do other things. So that's my kind of indoor tiny version of it.
Yeah.
With less robotics, and I'll talk about one with more robotics during my presentation. Has anybody tried doing anything like that, like growing food, hydroponics, any of that stuff? Nope. Okay.
No, I've entertained it, but never really had the time to really get into it enough to make it go.
I wonder, you know, James, maybe you have have read something or know something about this, but what about pests, slugs, you know, insects that you don't want around, rodents that will eat your radishes and your carrots? You know, do they give it a little like a laser or something like that to zap those guys? Or
You know, they don't, and that's one of the that hits exactly on one of the things where I think they could do better. There's a thing called a wire bot or a cable bot that I'm a huge, I just love wire bots. And the nice thing about a wire bot is that it could handle a much larger space for a much lower price, because all of that aluminum and CNC and Cartesian, you know, robot stuff is very, that's relatively expensive for the materials, and it covers a relatively small space. But if you use something that's on cables, right, you can cover a huge space, and then when it's not in use, the cable bot can pull back and fly sort of way up over the top, and then use the camera in a broad mode to detect motion. And then if there is any kind of motion, it could go down there and chase off whatever it is that's bugging the plants, right? And a rabbit or a raccoon or whatever that's coming out of the plant will definitely go, right? And worst comes to worst, you can squirt some water on it or something like that, assuming that you have the water tube, you know, hooked up for watering the plants. So I think that's a definitely an area that they go into. But the one that it can't help with, and the whole reason why I moved to doing indoor gardening with these grow boxes, I posted a link in the chat about it, is ants. We in Southern California down here, we had that huge invasion of the Argentinian ants a few years back. And Stephen, I'm telling you, it's incredible. Like, I don't know if you got them up there in Seattle. I don't think you did the way we got them down here, because they didn't get up into the colder climates. But oh my goodness, what happened was it was only one colony that got transported here on a shipment of something. I don't remember what it was. And so they didn't compete with each other. There was no genetic diversity between the Argentinian ant colonies, because they all came from a single source. So genetically, they all thought of themselves as being one colony. So they went out and unlike other ants, which would fight with each other over territory, the Argentinian ants just cooperated. You know, their warrior ants would meet the other colony's warrior ants, and they'd go, "Hey, bud, what's up?" You know, and just move on.
yeah,
And it was, for a few years there, Southern California was just one anthill, and they literally wiped out every other kind of ant. They killed all the leafcutter ants, they killed all the army ants, they killed all the carpenter ants, they killed anything that wasn't an Argentinian ant.
yeah.
And we're still seeing weird effects in our flora and fauna, because like there's certain plants that were dependent on leafcutter ants, and you know, when they died off, those plants they struggled, right? So what's happened now is that actually, as it happens, just a few miles from me in an area called Lake Hodges, there was two biomes, one that was really wet and one that was really hot and dry, and they were right near each other. And the Argentinian ants that lived in those two biomes started to diverge because they reproduced very, very quickly. So evolution was a little bit faster, than it would be among humans. So over the course of a few years, those two different biomes produced different ants, and they started fighting each other. And so there was suddenly this huge civil war in the Argentinian ant population. And there was entomologists down there. Entomologists, that's insects, right? Anyway, so. And there's another name for ant people who study ants. They were like tripping over people's backyards and stuff, like with you know, spyglasses going like, oh, here the line has moved this far today, you know. And literally there was this huge war going on down there. So now we're starting to see it recover. But during that time, you literally really could not grow anything outdoors in the garden because the ants would just come along and they farm aphids. They're literally little ranchers, and they will take and bite the leaves on whatever plant you plant so that the leaf curls up to make a barn. And then they will put aphids inside that barn and have the aphids suck the material out of the plant. And then they milk the aphids, who have evolved to produce, you know, a sticky, sweet substance that the ants like. And they just killed everything. So I moved to indoor farming to be able to do something, you know, and grow a little bit of my own food and experiment with it without having everything just destroyed by the Argentinian ants. We went to trees in our backyard, and we put tanglefoot around the trunks so that the ants can't crawl up and get into the leaves of the tree and kill it. Tanglefoot's a sticky petroleum substance. That was way more than you guys wanted to know about that. I'm sorry.
No, that's actually pretty fascinating.
Yeah. So I really think the indoor thing is the way to go. Just because then you can grow crops year round. You have something nice to look at, something to be proud of that's growing in your office space as you're working.
Mm-hmm.
You can reach up and I'll demonstrate real quick. You can reach up and grab a tomato and
Mm-hmm.
you can pop it in your mouth and enjoy a lovely little snack.
I like it. Huh. We just, my wife and I just spent 3 weeks in Texas. Are everywhere. You know, they make their, I mean, you walk down the sidewalk and you'll see these little tiny hills and piles, and they're just everywhere down there. And we were warned, it's like, don't step on those things because they will get on you very quickly, and they bite, and it's an irritating bite. And I was just astounded at no matter where we went, all you had to do was just watch for them, and you could see them. And of course, you had to be careful if you walk across the grass or something. It's very easy to step on one of their hills, and you know, it was just yeah. And you know, go ahead.
So let me tell you real quick. I'm 5 years old. I'm a little kid. I'm playing in the little empty lot behind our house. My parents had already checked it over and verified that area was, you know, clean. I was being watched, but they missed in the grass a red ant, a fire ant hill. And as a kid, I thought it was fascinating. And apparently I jumped into it or walked across it or something. Mm-hmm. And so my mom tells me that I was screaming and crying, and she came out and got me and took me to try to get all the ants off of me. And they were just literally everywhere, just biting me from head to toe. They put me in a tub trying to drown the ants, and because they couldn't get them off fast enough.
Wow.
And so slowly got it off. I swelled up. They took me to the emergency room. I had, you know, antihistamine injections, baby. So, okay, that was my first introduction. Now, jump ahead. I think I was 12 years old. My father had built our house in Oregon, a little town called Williams. And there was a piece of paneling that was on the ceiling over my bed. Unbeknownst to us, carpenter ants had gotten in there and had built an entire colony on the top surface of that piece of paneling. They ate through a lot of the wood, loosening the nails to the point that in the middle of the night, this whole piece of paneling came down like this and dumped an entire colony of black ants over me. I woke up screaming, covered in ants. So I tell you that story so that you will understand how much I don't like ants. Like literally, my wife cannot wear a dress that has a little polka dot pattern on it because part of my brain processes that as ants. So
Okay.
So yeah.
Yeah.
Anyway, I don't like ants. And the most amazing thing about it is that because of not liking them, I've studied them a lot. And let me just tell you, if you don't like ants, the worst thing that you can do is study ants, because the more you find out about them, the more powerful they seem to be.
Mhm.
At the age of 50 something, I have literally had nightmares about ants forming, intelligent colonies, because there's a type of ant that gets together every night in a big, huge pile in the Amazon forest for warmth. And there's these army ants, and they make what they call a bivouac at the end of the day, where they all just kind of clump together. And I had this idea in a nightmare that they only have like 100,000 neurons in each one of their brains. But if somehow those neurons were connected between the ants when they got into this bivouac, the thing could form a brain and become, intelligent. And at some point in time, they might get angry with us because of what we've done to the environment and decide to kill us all. Here's the thing. So the next day, I made the mistake of looking this up. You're not going to believe this, but not only the number of ants on the planet outnumber us, but that's like a factor of like I think it was like 1,000 to 1 or something. They outnumber us. The mass, the physical mass, the weight of ants on the planet outnumbers us 8 to 1. This was
Holy cow!
Okay, so if they decide to kill us, there's a good chance. Okay, now I'm going to have nightmares again. Just
yeah. Yeah, thanks, James.
James, do they know how to build and use flamethrowers?
Exactly. Dude, I don't like ants.
If we see them starting to mine petroleum, we've really got a problem.
Sounds like a good 1950s horror movie.
Yeah, there was I should remember the name of it, but there was a really good one where there was a research facility in the Amazon, and the movie ends up where they dig a pit and they capture 2 of the humans, and the ants are studying the humans instead of the humans studying the ants by the end of the movie.
Right. Oh, good grief. Yes. Let's see. I'm stumbled upon.
Steve's internet keeps cutting out. Is that just me or is it somebody else?
No, yeah, I'm seeing the same.
Yeah. It's not a, let's see, are you hearing me now? Let me,
Yeah, it only happens every once in a while.
Yeah, maybe I'll try just muting my video and see if that helps. Let me see here. So I'm gonna share this. Okay, so you should all be, well, let's see, should all be seeing just a YouTube screen there.
Oh yeah, this is a good one too.
Remember this guy? So
I'm Jeff Garner from Transport Canberra and City
This is
Services.
just a couple minutes.
Teams work hard to get on top of the mowing program, especially after the wet spring. To tell us a little about this new toy, Senior Manager with Place Management, Jane Carter, is with me. Jane, this is called the Spider Mower. What an amazing toy.
Yeah, the Spider Mower is a new remote control mower that we're using to mow some of our steep slopes around Canberra.
I guess it's all about safety as well and time saving.
Certainly time saving and safety. We've able to mow this slope here, what would normally take us 2 days with 2 staff, we're able to do in half a day with the Spider Mower.
And as you can see in operation here, the slope is quite steep here. We're at the airport right near Pialigo, and that's about a 45-degree slope, we think. And look at the way the Spider Mower can go in any direction. What a great idea.
Yeah, certainly. And with staff, when they're trying to whippersnip or brush cut this slope. It was such a task and a chore. You felt very unsafe.
Let's look at Matt here with his fingers doing all the work on the remote control device. Imagine having one of these at home. So look out for the Spider mower. That's part of the program here with Transport Canberra and City Services.
So this this mower is available here in the States. We happen to be up near let's see, Paulsbo. We were up on a road trip there on the Olympic Peninsula, and we just went to a park for lunch, and a guy pulls up in this fancy new pickup, and he has one of these machines in the back of the pickup, and then three guys in the for the workers for the city that do yard maintenance at the parks and stuff around the city were there, showing up at the same time, and proceeded to demo this thing for them. And it was a pretty cool. I mean, you know, the unit unfortunately sprung a hydraulic leak during the demonstration, which apparently they seem to be. I mean, the salesman wasn't overly surprised, like it sort of happens often. And so they popped the cover on this thing, and they were looking, trying to figure out where the problem, you know, where the leak was. And I'm logged in. I'm not going to be able to find it because I'm not logged into the. I don't think I've got it, and I don't think I got the pictures. No, I didn't upload the pictures to the Google Photos here. So anyway, we had to leave before they figured out where the leak was, but they had the cover off on this thing, so we were able to get to look at some of the guts and the workings of this thing. It's got some kind of a oversized lawnmower engine type of thing that powers it, and hydraulic system. The four wheels all can rotate. They all rotate together in whatever direction that the machine wants to go. So the thing can basically translate, and probably about maybe 4.5 feet square, I would say, and about 2.5 feet, maybe 2.5, 3 feet tall, and $40,000 for one of these cool things. And I'm guessing the guys that were there were probably thinking, yeah, let's get one of those, because you know, doing mowing grass on steep slopes I'm sure is not fun, and that's unfortunately a lot of parks are like that. Has a winch built into it that you can control from that remote controller that you saw in the video there, that allows you to strap the thing to a tree or a vehicle or something up on top of a hill, and then have the thing and actually drive the thing in whatever direction you want to go, and it'll keep it from slipping down the slope, or you can actually go up the hill, or you know, whatever. So kind of a cool idea. So let's see here. I'm going to since I guess I should put them both in here. I'll send or put the link to the other one in there as well.
So Steve,
yeah.
Does it automatically keep the tension on the winch? Is that how it works? So you can drive in any direction and it just follows?
I believe so. Yeah. The remote the remote control is actually pretty sophisticated. So I'm guessing that, yeah, you could pick a direction, and then it will use the winch tension to make sure that the robot stays on the track that you're trying to drive. So yeah, it's seemed like a pretty cool thing. You know, I could have hung out there for quite some time. My wife wasn't quite as fascinated by the machine as I was, you know. So once she was done with her lunch, it was like, okay, let's get on with our, you know, what we actually came here for. So anyway, there you go. So there's a link posted to both of the videos that I just showed you guys there in the chat. And let's see. So okay, so we're back to this. Let's go ahead and take. Oh, let's see here. Let me get the slideshow back up here again. I'm going to. Let's see. There it is. Share. Okay. All right, so you should be back to seeing a meeting slide there. And let's see, just before we take our break here, just brief, same Zoom link next month. I'll get the recordings, try to get them up on the website as soon as I can. But if you want to get to them sooner, go to our YouTube SRS Clips and More page. And anything during the presentation or anything that you think of that you want to share with everybody, throw that into the chat, please. And so coming up, we're going to take this. This is a video that was done a while ago now. It's pretty old, but I hope you enjoy it. It's about 6.5 minutes long, so we're going to make the break about that long. And and James Newton will be talking to us about something interesting, I'm sure. So here's a little a flash from the past here. And if you're Styx fans, you maybe enjoy this. We'll be going starting in about a minute or so, folks. All right. That was I'm trying to remember the name of the guy that put this together there. That was a number of years ago. Unfortunately, he was a kind of a sickly fellow, but he liked to do video editing, and he put this together for me, and unfortunately passed away not long after that. So, but figured I'd play that again here. Maybe I'll play this for you one now and then, just for fun. But so we have James Newton is going to be sharing with us about interesting stuff that he does. And those of you who have been online with us here over the last however many months there, you probably know him. He's always usually has something interesting to share. I didn't expect the story about ants this morning, but hey, that's so you always surprise me.
Yeah, that's one of the best ways of putting it.
Yes. So anyway, I will turn it over to James Newton of Haddington Dynamics, and why don't you go ahead and share? You have something you want to share on your desktop, or you just want to?
Yeah, I'll just share my desktop and jump back and forth between a bunch of tabs on the
okay.
browser here.
All right, so go ahead. You got a question there, Randy?
Have at.
Oh, you're muted, Randy.
You're still muted, Randy.
Still muted, yeah. There you go.
There you go. There you go.
I have to hold it up every now and then.
Yeah, go ahead.
We didn't hear what you said, Randy. Can you try that again a little bit slower, a little bit clearer?
Well, I've been having pains in my arm for the past week, and it hurts sometimes, and I have to hold it up to clear the pain.
Oh, you weren't raising your hand. Okay. We'll remember that. If you want, you can.
But I do appreciate
your video if you're concerned about us accidentally calling on you there. So, All right.
Yeah,
Well, anyway, take it
I
over,
do
James.
appreciate I appreciate the interaction there, though, Randy, because you guys have a tendency to just sit there. So because I don't have a presentation, I'm really hoping that you guys will be a little bit more interactive and will, like say, hey, that this is interesting or that's not interesting or whatever. I'm going to keep one eye on the chat. So, as you come up with a question, or if you don't like what I'm talking about, you want me to move on, just say so in the chat, and if I get a few of those, I'll actually follow suit. If you are interested or if you have a question, please interrupt me. I'll just unmute and ask a question. I'll be happy to try to answer questions for people. So I'm assuming that most of you saw the not the Roboticon. The Roboticon is the thing I'm doing for Hackaday. That's going on right now. The Robothon. There it is. Roboticon and Robothon. Too close together. So I did a presentation about the SDMG bot, little silly little low-cost bot that uses a web interface. And I was kind of just getting into the web interface part of that at the end of the presentation. So I figured what I would do is kind of go on with that part of it and kind of expand on some of the things that you can do with web interfaces. The things that I like the most about having a web interface on a device is that you don't have to install anything. There's no app. There's nothing. It's just a very simple. You have a device with a browser. You go hit the web page and you get back data about the device. So the other thing that I like about it is how incredibly simple it is to set that up on a device with enough computing power. So in other words, you can't really put a web interface on an Arduino. And the funny thing about that is that the thing that stops you from putting it on your standard Arduino is not the web server part of it. It's the TCP/IP stack, they call it, the levels of network interface protocols that you have to support in order to be able to get any kind of internet data to flow back and forth between the Arduino and the device. That's the hard part, believe it or not, the protocol. The actual web server is nothing, just nothing. And Arduino can easily be a web server. What it can't do is handle the actual communications. And so the ESP8266, which I absolutely love, was literally designed to facilitate that for the Arduinos. That's what it was originally made for. This version of it right here, which you can now literally buy for $1 or $2 online. This guy only basically has, I think, like 2 or maybe 3 GPIO pins that are useful, but there's a TX and an RX pin, and these were designed to hook up to an Arduino and then be used to provide this kind of a network interface. And I think a few of us are old enough to remember AT commands. Does anybody remember, the old modem AT commands, AT/DT?
Yes.
AT whatever. Yeah.
Oh yeah.
Yeah. Well, on the Hackaday thing, they had a trivia question about where would you find, between what 2 devices would you find an acoustic coupler? And that was one of the few that I didn't have to go Google to try to answer, because I've actually done the whole acoustic coupler modem thing, used the AT commands. So that was how you originally were supposed to use these things. But what somebody figured out was that the expressive chip that was actually on this device had, 32 bits of processing power in it. And if you bring out some nice GPIOs on the thing, you can, then actually if you could figure out how to program it, then you could use that instead of the Arduino. Like, why buy this, you know, at the time, I think it was like 30 bucks or something when they first came out. But, you know, why buy this $30 edition and then buy a $20 Arduino, because that's what they cost at the time, and then write your program on the Arduino? You know, why not just buy the $30 adapter and write your programming directly on that? And it was not open source. The actual, you know, thing was not open source, but they supported a language called Lua, and that part of it was kind of open source. You could kind of get into the guts of it by looking at the way that they interfaced with the Lua language. And so there was a group who reverse engineered the ESP8266 and figured out how to program it using the Arduino IDE. So you started being able to program these devices using just the standard Arduino, you know, C code, and going in there and writing, you know, programs for them that would run directly on the device. And then one of the very first libraries that actually was developed was MinoDev. Let's see whether or not I can actually pull him up really quick here. But they wrote a web server for it, and then he wrote this really nice web server for it, which supports a ton of different things. So basically, in your Arduino setup, you just, you know, pull in a particular library and start using it. He has a ton of documentation here, but let me scroll down to a like standard simple example. Wow. Okay, no standard simple examples here. He's showing you how to do all of the hard stuff. But basically, within a very few lines of code, you can just say, when I get a request, use the local file system, which the original version was called spiffs, to send back the contents of this file. And that's all that a web server really is. It's just, you know, you get a response, you get a request for a particular file, and the web server grabs the content of that file and shoves it out via the TCP connection to your local to whoever's requesting it. So we went ahead and installed it's called a Node.js language. Now, we at Haddington, for whatever reason, got really involved in JavaScript, which is, of course, the primary language of the internet. And yeah, thanks for the links there, Steve. And this Node.js takes the engine, which is the JavaScript engine inside the Chrome browser, and makes it available as a standalone programming language. So with Node.js, you can write JavaScript programs that you can then run on your PC. So one of the things that you can do is install Node.js on your local laptop. You can install it on the PC. There's a couple of different ways to do that. The way that I like the best is they have a thing called Node Version Manager, or NVM, which is a series of scripts. There's a version of that for Windows, there's a version for Linux, so on and so forth. If you install NVM, then you can let it manage what version of Node you're using. So you can then say, hey, NVM, install Node version 11.6, and it will install that, and then you can, you know, fire up and start using your web server or whatever server. Now, the other thing that's really cool about Node is that there's a massive library of it. So I started out a long time ago programming in Perl. Any of you guys Perl scripters from way back or used Perl? And there's a huge library of different routines, in the same way that there's a massive library of different C programs, massive library of Perl modules. And that was why a lot of people got into Perl programming, because you didn't have to write stuff. It was already written for you as a library. You just had to go find the right library out of the Perl library website, download it, install it, and away you'd go. So NPM is the Node package manager, and the NPM site just has this massive list of every possible library you could ever want. So there's one for WebSockets, there's one for processing form data from a browser. We install those into the robot. You can install those into your computer. You don't even really need that to get started. and then you just install your little web server script. And so I'm going to show you that right now, but I'm going to show it to you in a kind of an interesting way. This is the web interface to one of the Dexter robots. I'm being very careful here not to show anything that's proprietary since we were purchased. This is all open source stuff that's available for download. So this is just, you know, the browser is making a request to the IP address of the robot, and the robot is returning this web page, which has all of this information about the bot in it. You'll notice the nice logo here, powered by Ocado Technology since the purchase. You'll see that it's showing that there is errors in the error log, and those are just some servo responses, bad responses, because there's a power supply issue with this robot, this particular robot, where it's not giving the servos full power, so sometimes they have they throw errors. And one of the things that this robot serves up, just like the little SDMG bot that I was showing you the other day, is it shows up a web editor. And I'll go ahead and zoom up the screen here a bit on this so you can see things a little bit better. But, you know, all of the files of the robot are exposed and can be, you know, accessed through this. I'm not going to show you the contents of those, but I'm going to go and show you the content of the web server. So this is pretty simple code. It's just a series of library calls. Again, these are all the different libraries, like I was talking about, how there's one for WebSockets. There's one for access to the file system. This one is for access to for the browser to be able to post forms back to the web server. There's one for URL processing. This is the one for the web server itself. I have, you know, a little thing here that handles MIME types, which is just a stupidity that you don't really have to worry about too awful much. But I just want to scroll down here. There's a bunch of code in here for handling different functions and things that aren't super important. But this is the code for serving files, and you can see how simple it is. It's just, you know, we set a variable called share folder, which is the starting folder of the web of the share data where the files go. We add on the subfolder www, and we take the path name from the request. So for example, if you are requesting edit/edit.html, it will take this Search Samba share folder. It's adding in the www subfolder. Then it's adding in the edit folder underneath that, which it pulls from here. And then the edit.html file is what you're actually looking at. So this was actually served by this little piece of code right here. And then it uses the file system library to try to read the file. And if it fails, it writes back a 404 not found to the browser. Otherwise, it sets a header. That has to do with security. You don't need to worry about that. Figures out the correct MIME type. That's only important if you're going to serve different types of files. It sets the content type to that MIME type, says that this is a good response. 200 is the code, so where 404 is an error, 200 is yes, that's fine. And then it writes that data back out again. So that's the data, the content of the file, which was requested by read file. Writes that back out again, and then it ends the response. And that's all there is to it. That is a web server in short form. The only other things you need is something to parse the request URL, which is this, you know, this stuff up here, to extract out the path name, and then you just, you know, call that thing. Now I have a bunch of other handlers here, which are related to the editor, being able to get files off the file system, being able to edit those files, being able to delete one of those files. So if you look over here, I could right now delete the web server if I wanted to by just clicking on that. Don't do it, don't do it. Post is able to update files. So if I go in here and change something, then I can update it. And just to give you an idea, you know, this is a relatively complicated web page. But one of the nice things about HTML is you can generally look at it and kind of figure out what's going on, right? So back on that company homepage, you know, this is going to show up underneath that, and I can just write, you know, and then save the file and go back over, oh, sorry, back up one here and hit refresh, and, you know, there it is. So you can do the same thing with that little SDMG bot. you can just use it directly as a development platform without having to install anything. Now, one of the coolest things about that is that you can then make use of things that other people have written, not only hosted on your robot, but hosted from other places. So just one example of that is there's this chili pepper. It's called a hardware fiddle. But basically, it's providing web interfaces to relatively small devices. So there's a Tiny G is a I think it's Arduino based, if I remember correctly, 3D printer or CNC controller, primarily used for CNC control. And it's just a a little dumb Arduino that's just taking data and running with it. It has a serial interface. And what these guys have done is they come up with a little program that you install on your PC that just makes that serial interface available to the web locally on your PC. So all it is it's forming a wedge between a serial port and your local internet, intranet, if you will, on your PC. And then you can hit this web page and it will go out and talk to that device. And they've written this absolutely amazing 3D viewer. It's a G-code sender. You can go ahead and play this. You have to select the port. I don't have one hooked up, but you get the idea. You can view the G-code that's going to be sent to the device here in this viewer in your web browser and have this really fancy interface to your CNC machine or whatever without having to actually install anything on your PC. I just think stuff like that is just cool as heck. So all of that on a little $10 chip. We're hosting these files on the SDMG bot on the bot, right? But there's no reason why, if the bot is connected to your local intranet, that you couldn't then make use of it to go out and grab information from the internet in order to provide a more complicated user interface, something beyond what the robot could actually support loading itself. So the point here is that you can use the web interface on a smaller chip if you use some kind of a wedge to get in between the serial port and the actual web. So let's see, I showed you all of that. Let me just show you a few of the things that the web interface allows us to do on Dexter, which is pretty cool. One of the things we can do is actually run jobs on the robot. One of them, for example, is finds home. We can record and play back. Somebody, I think, was asking last meeting about being able to record and play back motions. We can do that just by hitting a button on the web interface or by running it on startup. You've already seen the file editor, allows me to access all the files on board the robot and edit them. There's a console, which allows me to go in and issue commands and get the really? Localhost is not found. Oh, that's interesting. Well. So other things that you can do with it, I've just recently added a history, so you can go back and see the commands that you sent before. So that basically allows you to SSH or remote into the robot very quickly. There's even a Scratch language, and this is a good example of something that you could potentially host, like just part of it on the robot, and then the rest of it could actually be pulled down from the Scratch interface. And this basically allows you to access through an add-in block a set of blocks that will actually move the joints on the robot to new locations. Really cool little interface that you can use, and you can run the thing just by moving it, or just by double clicking the block. You can put blocks together if you want to. Oops. Come on now. There we go. Put blocks together. So this one, if I do something like this, it'll first make joint 3 go down to 45 degrees, and then it'll make it go back up to 0 again automatically. I don't know if you can hear the robot moving in the background. I can't show it to you because it doesn't have the skins on it. But this is the sort of a full-on programming interface that you can add to a very simple robot project just by pulling down the Scratch interface and writing a little bit of code to make it connect to your robot. I'm going to go back here. I'm going to go back here. There we go. We also have a technical interface to the robot that allows us to just directly send commands to it, and that's really handy for debugging. So next thing I want to do is just kind of go over a little bit about HTML and the web. This is one of those things where you may just say, hey, this is too boring, I don't want to do that anymore. But this goes through just a very brief introduction to HTML and web pages and how to get them published on the actual internet as well as locally. So you wouldn't even have to install Node.js. You can just use GitHub to publish your web pages. And then a little bit with forms and JavaScript, and a little bit about animating the real world or automating the real world. So skipping ahead here, in case you didn't know, HTML just uses regular text. It's just normal text, nothing fancy. But they have these tags which are surrounded by greater than or less than that have a meaning. So if you put this little greater than be less than, and then the word is, and then a greater than with a slash be and greater than. I'm sorry, it's less than a slash be and then greater than, and it will show up like this. This is a test. The is will be bolded, right? So they're pretty simple little commands. A few things that you can do: italics and bolding. This is how it shows up. You can set headings with this H1, 2, 3, and it makes it a heading. This is how you do links between web pages. So if you want one web page to lead you to another web page, you just do the less than a, and then you specify this attribute called href. I don't know why they didn't call it link or target. There's href is such a stupid name for it, but that's one of the things you have to deal with. Equals, and then quote to the other thing that you do. You can actually get away with not learning CSS, but I'll also show you a couple of fun things that you can do with it, and that is part of the problem of having multiple languages. So anyway, you specify the page you're jumping to. You've got your greater than there, and then you've got your text that is the link, and then you have your /a. So if you actually click on that link, it then takes you to page 2, which won't work in this case because this isn't actually on a web server yet. You can include images just by specifying the file that has the content of the image. You can specify the width and the height of it, and a bunch of other things. You can do paragraphs. One thing to notice is that multiple spaces are not used. They all reduce to one space when it's actually put out there. So I'm just flying through this just to give you a real light touch of what it actually is. Most of you have probably seen this before. If you haven't, let me know that you want a little bit more of this, and I'll go into it a little bit more deeply. But that's your basic HTML document right there. It starts off with the HTML tag. This is the opening HTML tag. You'll notice that down here is the ending HTML tag with a little slash in front of it. They always have to be in pairs. Everything has to pair up, just like your parentheses when you're programming, right? If you have a head section and a title section, then that title shows up in the tab, right, of the web page. And then you have the body, which is where the actual content of it is. This is the main content, again, with a heading tab around it. This is, then what that looks like in the browser. Then you have to have your matching end body and your matching end HTML, and then you've got a good web page, and that is ready to go. So you can do this yourself. Use Notepad, any standard text editor, not a document editor. You can't use Microsoft Word. You can just use, Notepad or Leaf or whatever your particular favorite text editor for programming is. And if you put a little thing like that in there and you save that off as index.html, then you double click on it, it'll show you that actual file in your web browser. And more than that, this is the thing that just absolutely blows me away, is you can go to github.com, sign up for an account on GitHub. In the upper right hand corner, you just hit this little plus sign and say, I'm going to make a new repository. And you create a repository that is your username .github.com. github.io. Okay, so that's the name of the actual repository that you want to make. So on my account, James Newton, I have this repo called jamesnewton.github.io. Okay, so this is a little trick that, like, GitHub tells you this, but most people don't use it for that. Okay, and in here you can put in files. Like, here's an index page. It's a real simple little index page. I can edit this index page right here. So I can just say, you know, hi SRS, and I can save that file, commit the changes, go back and look at the main thing here, and I can have subdirectories. I can have as many files as I want to, and they're HTML files or JavaScript files or whatever. And then if I actually just make sure I'm not forgetting anything here. Yeah, okay. So you create a new file named index.html, you put that content into it, you commit it, and then you go to https:// your username.github.io. I will do that right now. If I go to this, you will see that web page that I just changed to say hello SRS. And that's literally all there is to hosting a web page. It absolutely blows me away that people pay money for hosting sites, and they pay somebody else to set up a web page for them, and they go through all of this garbage in order to do it. And literally that's all there is to it, at least to get started, to do something simple, right? So in this case, you're hosting static pages. So there's all kinds of cool stuff that you can do with this, and I'll get into a little bit of that a little bit later. I've been using it to even like host, presentations, classes. So for example, here's one I did on using servos with ESP8266. And I used an external library that turns the single web page into a series of slides. So you can see that, for example, I'm on slide number 1 here, and I can either just click the page. No, I can't click the page. I can use the scroll wheel to go to the next page, or I can change the page here. And it even though it's only one file, it just pages through it for me. So if I go back to the actual source code of that, and I look into this one, what you can see is that is this file right here. And what you'll notice is that I have this script in here that just calls this library that some other guy wrote called remark.js. And what that does then is it takes the content of the file that I made, which is this ESP8266 servo.md file, and it presents it as a presentation. And that file is in one of my other repos. So anyway, really simple, really easy to do. I super recommend that people just get started in the web by doing something like that.
James?
And thanks. And I should probably share a link to this document in case anybody is interested in it. There we go. So there's a 1,000 different. Go ahead.
Oh, so the .md file. What did you use to create that?
It was just created directly on GitHub as a file through the web editor. And I could.
So that's the extension of their web editor. Is that it, or is it a text file?
Yeah. So in the same way that I have this web editor here on Dexter, and I have that web editor on my little robot, GitHub has a web editor for files on their website. So for example, this little README file right down here is this file right here. And if I click on that file and then I click on edit, okay, see there's the content of that file. And I can just.
So it's just a text file.
It's just a text file. And all web pages are just text files. There's nothing exciting about it. So I make my changes to it, I hit commit, and I'm done. And what's really great about this too is that GitHub is also giving you all of these other fantastic freaking features, all this timeline stuff where I can go back and see exactly what I have done on any other commit. So it'll show me like between the previous version and this version, this is what's changed, right? So what did I do? I just changed something, didn't I? Changed an index page. So if I go in here and click on that commit right there, you can see it used to say hello world. The word world was removed. The word SRS was added, right? So it's showing me exactly what that commit was, right? And if I want to, I can revert to any one of these prior commits with just a couple of clicks. It's super easy to do. And if I had put in comments, it would have allowed me to keep track of, information like why did I make that commit, and so on and so forth. So just an absolutely fantastic tool, and I really think more people, should use it if at all possible. So moving on, I just want to go in real quick in a little bit about, there's 1,000 different resources out there for HTML. They're huge. It's really easy to learn. A couple of things that people get confused about, just real quick. Remember that all of the tags start with this less than symbol. So if you want the less than symbol to show up in your HTML, you can't just type in less than in your text. That will not show up as a less than. You have to use amp LT semicolon instead, okay? So if you say amp 1 amp LT semicolon 10 in the math I learned, then you will actually see this, 1 less than 10 in the math I learned, okay? If I use 1 less than 10 in the math I learned, what you will see is 1, because it thinks all the rest of this is an HTML tag, okay? So that's the first thing that is a little bit confusing about HTML. You have to watch out for that. Every opening tag needs to have its matching ending tag, and there's a structure to the document: HTML, head, title, end of head, start of body, start of head, end of head, start of paragraph, start of bold, start of italic, end of bold, end of body. You see, it all has to match, right? So that's really, that can be, difficult. People will mess that up. The thing about not having multiple spaces, you can't space things out and get them to move where you want them to move. What you can do is you can use this ampersand NBSP semicolon, and each one of those, that sequence of how many characters is that? 1, 2, 3, 4, 5, 6. That 6 characters represents one hard space, and that will actually space things out if you use a bunch of those. HTML by itself is not for drawing charts or whatever other forms of graphics. There's a thing called Canvas that is now available in the more recent versions of HTML that is used for that, and you can do some really beautiful things with it. And then the image height and width are measured in pixels primarily, and there are ways of getting around that. You can specify other things, but just keep in mind that this is designed for a screen, right? So you're working with pixels. Tables are a cool way of kind of giving a little bit of structure to things. They're kind of considered old now, but I like them and they work well. So you get this idea that you start a table row, you start a cell, and then you end a cell, and on down until the end of the last row and the end of the last table, and it shows up like this. So one of the things you'll notice about this, for example, is that this line is kind of a gray color, and it is a width of 1. The text is, I don't know, some Helvetica text or something like that. Things start off with a particular appearance, and where CSS works into that, and I don't do a ton of stuff with CSS, but where CSS works into that is that it allows you to do more fancy things. So just as an example, in this file, which is called loading, there's some multiple different types. So you'll see that's not 100% necessary, but here's your HTML opening tag, here's your head, here's your title, and then there's this tag called style, and this starts here and it goes all the way down to here. That's the ending style tag. So all of this stuff in between is CSS, okay? And what CSS allows you to do is it allows you to change the default appearance of something, okay? So one of the things that you can do is you could say, for example, that if I wanted the border of my table to be 8 pixels wide, and I wanted it to be a different shade of gray, I could do that. Or if I wanted it to be blue, or if I wanted it to be something else, I can change the radius of the outline. So there's all these different settings, and it gets complicated really freaking quick. But you can do cool stuff with it. The point is, this is the artistic part. This is the ooh, I don't like the look of it part, where you could go in and change, quote quote, the look of it. And what I typically end up doing is I find a website that I like the look of, and then I look at the source code of it and steal their CSS. So the CSS can be in the HTML file. You can also just have a style src equals, and then it'll specify a file name, and that file has the CSS that makes the display happen. Just to show you what this looks like. Good grief, what just happened? Okay, here we go. Let me select this real quick. Go back and show you. Maybe I should show it to you in a new web page. I'll open link in a new tab here. I want to go back in and actually be able to show you the text of that. This is just a kind of a fancy little trick they did. I think that's the right one. Yeah, okay. So this is for a loading page to show something to the user so that they know that the page isn't dead. And you'll see this thing, you know, slowly rotating around. Take a look at this CSS. This just kills me. What they did was they have this one little area on the web page inside the body called loader, and it's of class loader. And this dot loader right here is the class, and it specifies the border, which is the width of that line right there, and then the gray and the blue, those are the two different colors. And then it specifies an animation that's supposed to take place over the course of 4 seconds. It's a linear animation and it's infinite, so it means it keeps going. And this it's this keyframes animation down here called spin. So this is animation spin. It's referring to that spin, and it does a rotate from 0 to 360 degrees. So normally this would make a square that would rotate in space. But what they've done here is they've said that they want the border radius to be 50%. And if the radius of the border of your square is half the size of the square, then you get a circle. Isn't that tricky? So I think a lot of people get scared off from doing stuff in HTML because CSS is like a whole nother language, and it's tricky. A lot of it is tricky. So my advice is just ignore CSS and do simple stuff like this, right? Very simple web page, same structure. The only thing that's new in here is I'm using UL to start a list, and each one of these is a list item. And if you look back over here at that web page, there it is. It's a really simple little web page. So start off with something easy and keep going further. So tables, there's examples on images. I want to kind of rush through this because I don't want to spend a ton of time on it. One of the things I really like doing is using forms, because forms give you a place to put things. And we will jump really quick to that particular page. And there it is. This is, let me bump up the volume on this a little bit here so you can see it. This is the actual HTML of this web page. And you'll see here that we're starting a form. On submit is return false, meaning don't actually submit the form. Please enter your name. Here's the please enter your name up here. Here it is in the HTML. There's an input, type is text, and the name of the input is called input, okay? There's an input type button with a value of enter. There's the button right there. That's that. This is the text input that we were talking about. And on click, in other words, when somebody clicks this enter button, what it's going to do is it's going to go grab this form output value and set it to high plus this form input value. So this form input whatever the value is that was put in here is going to go into this form output, whatever the value is. So if I put in, you know, James and hit enter, it'll say, hi, James, right? So you get the idea. It's JavaScript can just be embedded directly into a web page, and you can make it do stuff that's active, you know, with that. So we'll close that, go back to this. So, you know, I would encourage people to just play around with, you know, simple stuff like that, right? One of the things so JavaScript allows those static web pages to then become dynamic web pages, and you can actually do stuff with it, which I think is really, you know, fantastic. One of the things that you can do with it is you can directly control the content of the web page. So if you write a web page, which is just, you know, HTML, we're not even bothering with the head or the title or any of that stuff. We just go right into the body. We're starting up a script. So now we're in JavaScript instead of HTML. And we do a document write, hello world, and that's the end of our script body in HTML. And when you load that web page, it just says hello world, right? So relatively simple stuff. So this is that same, you know, example that we were talking about before, where you know, you're doing this submit and it's doing something. You can actually make it do something useful, for example. So you can go to take care, Lloyd. You can actually go to this one. Get this to come up here. There we go. This is a slightly more complicated one. We have an input of type text with the name of input 1. Then here's the plus sign right here, and then here's the input 2. The button has an on click that sets the output. There's the output field down here. Sets the output to this form input value plus this form input value. There's a new thing here called parseInt, because JavaScript is a little bit stupid. It overloads the plus operator to be append if you have text. If you have a string, it appends the two strings to each other. If you want it to treat that text as a number, you have to do a parseInt. So, you know, for this one, you can put in a 1 here, you can put in a 2 here, you can hit enter, you get a 3. You know, right? So the idea is just that you can actually use JavaScript to do, you know, useful work. Actually, yeah, this is the one without the parseInt. So just to show you what happens, if we put 1 here, we put 2 here, what you get in the result is 12, because that's the string 1 plus the string 2, meaning append, and then you get the string 12 out of it. So you can go through and start building up, you know, start playing around with it. One of the things that we can also do is we can use the JavaScript on click things to actually change the content of the web page. So just to show you how that works, so if we go here and we actually click on the web page, you can see that that high is changing to low. And all it's doing is it's looking at the content of this span, and it's saying if it's this, then change it to low. Otherwise, change it back to high again. Right? So this is how you can make web pages come alive. So just to show you some of the things that you could do, this is a game of tic-tac-toe that was written entirely in JavaScript. So, you know, you click the buttons and play, and there's no way that you're ever going to win, right? But you get the idea. You can make web pages that are actually interactive and do, you know, fun things. A little bit of explanation on that. There's some just absolutely amazing things, you know, date and time display, drill and tap calculator for anybody who does metalwork or robotics. This is a script that actually just does some calculations to find different common bolt sizes. So if you have a number 440 screw, it will tell you not just what is the right drill for tap, for drilling a hole to tap for a 440 screw, but also the ones that will give you tighter or looser threads. So if you want a 440 hole that's really loose, you can use a number 42 drill. And if you want one that's super, super tight, you can use a number 46 drill, and it'll almost be self-locking. So there's all kinds of really useful little things you can do with forms and calculators. Loan calculators, resistor finder. Oh, this is a fun one. I like this. If anybody's into electronics, you'll enjoy this guy. So everybody has these little calculators on the web that you put in a particular value, or you put in what the colors are and it tells you what it is. This one, you put in a particular value and it shows you what the resistor looks like. Draws a little picture. And these, by the way, this graphic representation of a resistor is nothing more than a table, with each one of the table's elements styled to be a different color in order to build up a low resolution picture of a resistor. How funny is that, right? And then you can also do a thing. Let's say that I want a resistor that is 1, 2, 3, 4, 5 ohms. That's what it would look like if it did exist, but of course it doesn't exist. Instead, what we can do is do a resistor pair search, and we can find that, you know, if you took a resistor of that value and a resistor of this value, and you put them together, this would be the final actual result of that. Right? So if you scroll through this, you'll see that there are different values where this percentage of error here gets, you know, pretty low, and that the one with the lowest is presented right here. Right? So if you do that value resistor with that value resistor, then you will actually end up with that value. So all of this was done with JavaScript, right? And anytime, you know, you want to, you can just look at the source code of the page, and as you go down through it, you know, you'll find all the different stuff. You know, here's the array of the different resistor values. Here's the little, you know, calculator that figures out how to do it. You know, once you know how to do it, you can write this code and do something fun with it. So I think, how am I doing on time, Steve?
Well, we're just about 5 past noon, so you know, you can wrap it up pretty much any time you like.
Okay, so let me just finish up a couple of things. One of the things that's a problem with the web is actually interfacing with real life devices. Not if your device happens to be an ESP8266. Obviously, that's pretty easy then to interface with the web page. But just if you're in your browser and you want to interface with something, there's all kinds of ways that you can do that. You can, where was it? Oh, okay. I don't know where I put that. You can use your cell phone and interface with the sensors that are inside the cell phone. And there are some programs that allow you to write JavaScript apps and then run them. There's one called Android Script that is just an app that you install on your cell phone, and then it allows you to access all of the stuff on the cell phone easily, still using JavaScript. You can do, you can use the speakers on your cell phone or on your PC to actually run run servo motors. So this is a little thing that allows you to just take the sound output from your cell phone, and this code, which runs in the cell phone in the browser, actually produces P2B-M signals to run the servos. So you can run a couple of servos off of that. And our robot uses JavaScript as well. So that pretty much takes care of all of that. Let me just jump through this really quick. One of the things that really confuses people, and it's really a problem, is HTML itself is pretty simple. JavaScript is pretty simple. The problem, this is the thing that trips people up, and it's the most difficult part of it, is that when you use JavaScript to change the HTML in a web page, you have to go through something that's called the document object model. And the document object model is not a one-to-one relationship with the HTML. So this, for example, this relatively complicated map tries to show you how you get to a particular element of the document by using JavaScript. So for example, you have this HTML tag, you have this head, you have the title, there's the inner text of the title, But in order to get to it, you don't go document HTML head title. It's just document title. So document.title inner text gets you to the actual content of the title, right? You don't necessarily go through document body to get to the other elements inside the body. You instead go through element arrays. So for example, if you want to change one of the images in a document, you don't go document body image whatever. You go document images and then a subscript, and then you actually get to the image and its source. So that's something that trips people up. It gets very confusing. CSS is another thing that gets pretty confusing. And the only other thing I really wanted to show you was wire bots. And it turns out that that's a whole nother talk. Since I spent all my time yakking about JavaScript, I'm not going to go into this really quick. But the idea behind a wire bot is just like what you've seen on Skycam or something like that. You should be aware that there are people who have built 3D printers that these elements that you see here are the frame. They're not actually the part that's moving it. The part that's moving it are wires that are almost invisible there. And just to show you, you know, what we're talking about here, see if I can get to it really quick. This is a quick video with an ad. It's always got to have an ad that actually shows. Can you see the wires there in the air? And you see the stepper motors are down here. This is a pulley that this cable is being wound up on. And as the cable is being pulled, then it moves this back and forth. This pole right here in the center is providing tension to keep that bottom part forced down and into a particular location. So just to show you a better view of that, if I can really quick. I'm teasing you with this because I want to come back someday and give you a talk on how this can work. You can see the stepper motors right there running those cables, winding them up and unwinding them, and they're controlling the print head and moving it around. Isn't that freaking amazing? Does that not just blow you away completely? And what's completely amazing about it is because it's just wire, the mass of the thing is so low, the mass of what's being moved around is so low that the limiting factor is how fast the extruder can actually move. That's not sped up. And you probably can't see that all that well through the Zoom chat system anyway. So I'll go ahead and post a link for that in there for you guys to watch. All right. And I will stop there. Thank you so much for your patience. I wish more people had asked questions, but I hope I answered the questions that were there.
Anybody got some questions? I know I would love. Oh, go ahead.
Yeah, I had a question about the 8266. You said that they were trying to reverse engineer it, and they found that it was programmed in Lua.
No. The processor itself is actually, the source code I think is written in C, because that has eventually been released when the Chinese company finally realized that it would be really good to go open source and attract the open source community's attention. So it's written in C, but the C code that comes in the device when you first buy it has an interpreter or an executor for the Lua programming language. So if you buy one of these devices off the shelf and you connect to it, there is a Python-based downloader that you can install on your PC, and then you can download Lua code directly into the device and it'll run it directly. The reverse engineering then was to replace that C code with the Arduino code that you program in the Arduino IDE. Does that answer the question?
Okay. I was wondering if like what they did in the reverse engineer was to essentially write a compiler that converted from C to Lua or something like that. But no, it sounds like they've done a better job than that. They actually got to the bare metal.
Yeah, the manufacturer sold the chip, the processor chip that was used on the device. They sell that separately. It's Expressive. I can't think of the name of the chip actually. Extensia. They call the chip the Extensia. And so there was all kinds of different. There was a C language compiler, a GCC implementation to compile code, C code for that processor. So that part of it was already taken care of. It was mostly just figuring out how to use the libraries that were on the chip for accessing the Wi-Fi stack, for accessing TCP/IP and accessing the GPIO and all that kind of stuff. Okay. And there was a little bit of documentation available for that. So, you know, they just had some work to do in order to reverse engineer it and make it Arduino compatible. But you can go and download the Arduino IDE. You can add in a, what do they call it? Board support. There's a thing under the Arduino IDE where you can go in and download support for other boards. And the ESP8266 is one of those boards. And then you program it just like you would in Arduino. You can use all the standard Arduino libraries, wire and servo and, you know, PWM and, you know, all of that kind of stuff. It's all available. And then on top of that, there are libraries for, hey, let's add in a web server. Let's add in a, you know, WebSocket server. Let's add in a, now they've got some of them that actually have cameras on board. So there's libraries for doing vision processing. And there's all kinds of crazy stuff that you can do with these ESP8266s. There's an ESP32 with a camera on it for $16. I mean, it's basically a webcam that you can program. How freaking cool is that? And I've bought two of them, and on both of them the lenses were unfocused, which pissed me off to no end. And they'd epoxy stupid lens to a particular location, so I couldn't fix it. So I'm waiting until there's better versions of that. Cool stuff that you can do with it, really. Has anybody at all tried the ESP8266s or the ESP32s? Nobody? Anyone?
There's a little, I can't remember what it's called, but there's a little orange block with a color LCD in it. I can't remember what it's called, but I programmed that for a while. I think that's got an 8266 in it.
Is that the SON-off? SON-off light? No, that's the SON-off is the outlet that gets controlled.
It's M5. Does that sound right? It's something like that.
There's a bunch of them. You remember when you used to be able to get those little push button things for Amazon that you would push the button and it would order something for you in one whack?
Okay.
That was a big thing for like a year. Everybody was like, "Oh, this is so cool!" Like you could put one that orders, like, you know, dryer sheets or something, and it literally had tape on the back, and you'd stick it on the wall with a little label on it that says "Order dryer sheets." And so if you were in your laundry room and you realized that you were out of dryer sheets, you'd literally just reach up and push this button. Anyway, those were ESP8266s inside. And for a while there, you could get them for like nothing. Like literally, you could tell Amazon that you wanted to use one to order something, and they would send you one out for free. And they stopped doing that as soon as people started realizing what was inside. But the SON-off outlets are they're Wi-Fi controllable electrical outlets, and those are an ESP8266 inside. There's a ton of devices that have them. So yeah, I really recommend getting involved with it because it's a lot of fun. Frustrating as hell too, but a lot of fun. We wouldn't be involved in robotics if we didn't enjoy being frustrated, right? I don't know about you, but I think we all have to be a little masochistic in some way, right?
Right. So this was the kit that I got. This kit to do robotics with kids, and you can see the that's an ESP32. If you can quite tell, exactly what it is, but that little camera module there that allows a cell phone interface to control this guy. So,
okay. Yeah.
yeah.
So this
and
this is actually kind of a
Arduino basis. You
right?
can see that's an Arduino Uno underneath the sheet for the robot.
Right.
And so it does the basic motor control and that sort of thing, and then the little this module just takes care of the communication with the cell phone and an interface, that they built to run on the cell phone to be able to drive it. So
so this is for remote control, but also because you can reprogram the ESP32, and it actually has, fairly good horsepower on board. I've seen some of these where you can actually program the ESP32 to respond to the images that it's seeing, directly, so that it can actually be like a little, rover on its own.
That sounds really cool.
Yeah. And I didn't see the price on that, but it ain't that much. I mean,
right now it's listed at $76.49 on Amazon. you can't buy pieces for that. It's crazy.
So another little story from my childhood. This is what was this? This would have been late 70s. Okay. Somebody from your organization, this is your fault, Steve, went down to OMSI, the Oregon Science Museum, the Oregon Museum of Science, and something like that. OMSI was the name of it. And then there was a SWAMSI, which was down in Eugene. And they were holding these robot competitions. It was a firefighting robot. So there was a maze and a candle. And the point was you had to navigate the maze and then you had to find the candle and blow out the candle. Okay.
Mm-hmm.
And so it was hosted at OMSI and SWAMSI, but it was basically put on by the SRS, if I remember this correctly. Put it this way, I found out about it because of the encoder. So that's how I knew about it. And my father and I entered, and we spent, I think, $400 buying Polaroid ultrasonic sensors and trying to get them to work. And we burned out, I don't know how many of them. They were a complete nightmare. We could never get them to work. We ended up building, I think we had 2 weeks left, and we built a completely different sensor system, which worked absolutely fantastically, which involved a fan. So what we had was a fan on the top of the robot that blew air down, and then there was a cone that made the air direct out on all sides. So it was a round shape, but it had this conical like this. The fan would blow down and the air would go out in every single direction on the top level of the robot. And then underneath on the bottom level of the robot, there were little flags hanging down. And what would happen is if you got near a wall, the air would go out, hit the wall, blow back and hit the fan. If you were out in the middle of something and you were driving along straight, the little flags might flutter a little bit, but they wouldn't move. But as soon as you got close to a wall, that stream of air would bounce back and move the little flag, and so you knew you were close, right? I have never seen that done, not once, ever since, but that's what our robot used. And what we thought was really cool about it was that it would blow out the candle. We didn't have to worry about detecting the candle. We just figured when it went past, it would blow it out. We navigated the maze faster than anybody else and were disqualified because we did not detect the candle. We just blew past it, blew it out, and kept going. But my point is, we went through. I probably went through $300-400, and that was with us building the whole body of the robot ourselves in my dad's machine shop. So being able today to be a kid and build a robot for $70 that has all this brains on board and all of this code that other people have written to make it work. It just, it boggles the mind. And then, there the kids are playing on their Xbox instead of building robots. What is wrong with this generation? Kids these days.
I remember I first got involved with the SRS around the time that they were doing the firefighting contests, and they were there was some pretty ingenious solutions. Some worked pretty well, some didn't work at all, and And yeah, a few of the guys that are hanging on the line here probably remember those good old days. But yeah, it's so astounding what the technology is off the shelf now compared to even 10 years ago. I mean, and it's crazy.
Moore's law, right?
Yeah, yeah. Well, anybody got any final questions there for James?
Did I inspire anybody to actually try to build a web page and host it on GitHub or put it into an ESP8266? If I did and you have problems, don't hesitate to give me a ring. You know how to get a hold of me.
Okay, yeah, appreciate that. I know the SRS website, the old version of the SRS website was created purely in HTML and used a lot of CSS to do some pretty cool things that I kind of had to figure out. When I took over as webmaster, I had to go back in and study the code and figure out how things worked. And actually it was surprisingly clever because it was created about 20 years ago. And so there was a lot of things that, now you can just buy, or you don't have to buy it. You put WordPress on there and you can just do things. But back then, if you wanted any of these fancy transition effects and custom coloring and all that, the web feel, the look and feel, you had to create that yourself.
Sorry, that's my.
Oh, is that a video running on your computer there?
No, that's my robot, the Dexter arm. I have a voice interface from it so that it can warn me about things that are going on with the network. We were debugging some network issues, and so every now and again it and you know what? It's funny because it seems to wait until I'm on a video call, and then it will, right in the middle of some important point or something being made, it will shout out that it's IP address change. That was just a DHCP refresh with the local router. Sorry.
There's probably a little artificial intelligence under the hood that you don't know about there.
You start to wonder. After a while. Yeah.
All right. Well, thank you so much for sharing with us. This was actually fun, and yeah, appreciate your doing it. You bailed me out since my previous presenter there. She had to bail on me a month ago, and so I appreciate that you were able to fill in for us. And I will have her back, but she's going to be having a baby, and so she's like, she didn't really want to commit until that was all kind of done and over with, and she could kind of see how her life, if her life would allow. Thank you again, James, and thank you everybody else for joining us. I'm going to go ahead and stop recording here.